Hello everyone, today we are going to solve problem move zeros. So first let's read problem what the problem saying. So we are given an integer array nums, move all zeros end of it while maintaining the relative order of the non-zero elements. Okay, we are given note as well. So the note saying you must do this in place without making a copy of the array. So we have to write an algorithm which take constant space means we have to modify this nums array itself. Okay, so let's analyze this problem carefully and let's see what algorithm we can write which take constant space. So this is the nums and the problem requirement is we have to move all zeros to the right while maintaining the relative order of the non-zero element. Means if before moving 0 to the end, if the non-zero element order is like this 1 3 1 2, so after moving all zeros to the end, the non-zero element order should still stay the same, like 1 3 1 2. Okay, so how can we do this? So the very simple idea is we can solve this problem by using two pointer approach. How? The idea will be very simple. Okay, what we will do in this approach, we will keep two pointers L and R. I keep moving my R until it point to non-zero element, and once my R is pointing to non-zero element, in that case I will swap my L and R and I move my L by one place. So let's understand how can we do this. I'm saying I will use two pointer L and R. I will start both from index 0 from the same index, and I start moving my R. When my R pointing to non-zero element, in that case I will swap my L and R. So in that case I will move my R. Now my R is pointing to non-zero element. I will only track my R. Whenever my R pointing to non-zero element, in that case I will swap. So when I swap, my 1 goes here and 0 will come here, and I will move my L pointer by one place. Now my L pointing to this element and R is also pointing to this element. Now I again start moving my R until it points to non-zero element. Now my R was here, still it is 0, so I move my R here. Now my R pointing to non-zero element, I will again swap both L and R. Now what happens? My 3 will come here and 0 goes here. Now I will move my L by one place and I start moving my R pointer again until it point to non-zero element. I will move my R. It's again pointing to non-zero element. What again? I will do the same. I will swap. Now 1 goes here and 0 comes here. I again move my L by one place. So just move this L by one place. Now again moving R. Now I'm again pointing to non-zero element. In that case, I again swap. Now my L goes, my 2 goes here and 0 goes here. And once my R reaches to end, I will end my algorithm. This is the simple logic. Okay, let's analyze on another problem where my first element is non-zero element, so that you get better understanding. So let's take 1 0 2. Let's separate by comma. 1 0 2. So again I will use two pointer. My L is here and R is also here. So what I can do, again I start moving my R because my R is point. What I will do in this case, my R pointing to non-zero element, so I have to switch because my algorithm says whenever R pointing to non-zero element, I have to swap L and R. I will swap since my L and R both pointing to non-zero element, same element. So after swapping, they will stay same. Now I move my L by one. Whenever I swap L and R, I move my L by one place and I keep running. I always move my R whether it is 0 or 1 non-zero element. So I move my R as well. Now my R is pointing to non-zero element, means now my R is pointing to 0. So what will I do? I again move move my R pointer so that it points to something non-zero element. Now my R is pointing to non-zero element and L. So what will I do? I will simply swap. So I will swap. Who will go here and 0 from here, and I will move my L by one place. Now what happens? My R again move, and this time uh, my R reach the end. In that case, I will end up my algorithm, my while loop, and this will be the logic here. I didn't use any extra array, and I am able to move all zeros while maintaining the relative order of non-zero element. So let's see how we can code this. So we know what we have to do. We have to take two left pointer. One is a left pointer which start from zero index, and another is R pointer which also start from index 0, and I will use a while loop where I start running my R until it reaches the nums length, means end nums dot length. Okay. Now what I will do? I will check if my R, I will only track my R. Okay. I check if my R pointing to non-zero element, what I will do? I will swap. How can I swap? I will use a temp variable, and I know how to swap logic. What can I do? Here I will store my L, L element, which means the element that L is pointing. Now what I can do? I will swap at R. I will place my nums of L, and at now R, at nums of R, what I can do? I will place my temp where I have stored my element which where L is pointing. So this is the swapping logic. What I will do, whenever I swap, I move my L pointer by one place, and in every case I will move my R pointer because I have to run my R in every case, whether it's 0 or 1. So it keeps running. So this is the whole logic. Here we don't have to return anything. We have to uh, we have to, what we have to do, we have to change this nums itself in place. So I don't have to return anything. So I can now simply run this to check whether it's working or not. Okay, this giving me error because I made everything 0. Why? Let's check what happened. I start my L and R. I keep moving my R. Now, if R is not pointing to 0, what I am doing? I am taking L at, I am using temp variable to store my L, and now at R I am placing L, and at R I am placing. Okay, the logic seems correct. Then what's the problem? Why my array gives me 0? Here my output is 0. What's happening here? At int temp, I am moving L pointer also, R is also, swapping logic is also seems correct. At temp, I am storing L. At R, okay, I am doing this thing twice now. Okay, got it. At L, I have, no, at L, I okay. The flow is in my nums swapping. Oh, okay, I got it. So let's at I have stored the element pointing by L. Now at L, I can place R, and at R, I can place my temp. Okay, this is the correct idea. Let's run. Okay, this working. Let's submit it as well. So I'm just making a silly mistake here in swapping logic. Now I have corrected. So this giving me a decent time complexity, which is good. Let's analyze what the time complexity and space complexity this algorithm taking. So here I am. traversing over my array once, this while loop running once only. So in this case, my time complexity is linear. And what the space complexity? So I'm not taking any extra array or any collection here. I'm just using two variables which say constant space. So for this algorithm, my time complexity is linear, which is n length of the norms, and my space complexity is again constant. So this is the solution for this problem. Thank you for watching. If you like this solution, please consider to like and subscribe my channel. Thank you so much.